Sweet.
Hi, everybody. I'm Maddie. I'm the organizer for the Meetup. Thanks for coming out. I do talk about the Meetup occasionally on that hashtag, and that's my Twitter handle, in case any of you are unfamiliar with that. Just want to, real quick, as always, thank our sponsors. Sticker Giant's been really good. They give us our free stickers, so I have tons of these tonight if anybody wants one. Thanks to my lame co-organizers who actually aren't here tonight. They're variously taking care of babies. But they've been really helpful with hosting and organizing. Thanks to my employer, HY Connect, for letting me blow off work to organize this, and also they picked up the tab for the pizza tonight. And lastly, my other they're not here either. Awesome. TableXI is another organizer. They actually have helped us out a lot with getting speakers and organizing as well. And lastly, thanks for these wonderful folks here for hosting us tonight. Having this regular space has been really helpful because we don't have to scramble to try to find a place to fit 100 people every month. So thanks to them. Last couple things. If you guys haven't seen these on the site yet, we've scheduled 2 events for next month. The membership is getting big enough that we can fill up a room twice a month now. So we're going to try to keep going with that for hopefully the whole 2014 calendar. We have to schedule November yet, but we are going to go on hiatus for December because everyone's busy and has other stuff going on. That's it. That's me. I'll turn it over to David from Belly.
Is this already on? Hey guys, can you hear me? Thank you. I just got to switch over my computer. That was easy. Great. So what I want to talk to you about today is HTML5 mobile apps, and hopefully give you some pointers on how to make them suck less. If you've ever tried creating an HTML5 mobile app, you know that it's not exactly an easy environment. Real quick, I'm from Belly. How many of you guys use Belly? Quite a few of you. Great. Awesome. So what we do is we have a digital loyalty platform allowing you to check into businesses and earn points. So let's dive in, right? Let's take a look at native versus HTML5 mobile apps. Now, by mobile apps, I mean like the mobile web. So web apps that you would go to in the browser. When looking at dev tools, I mean, in the browser environment, it's kind of difficult. We don't have the best tools, compared to any sort of native language. We don't really care too much yet. I mean, we're getting there about memory and such and all that kind of stuff. And we have tools to see into performance, but it's not been the greatest. When we're talking about mobile apps, though, it's even worse. Even for native, I mean, we're dealing with multiple platforms and OSs and operating systems and web browsers. So either way, though, native is still better. They've got pretty good tools, and developers are creating pretty cool libraries and frameworks for native as opposed to HTML5. Performance, right? There's no doubt. Nobody can argue that JavaScript is faster than most of these native languages. Inherently, native is faster, right? What about user experience? I mean, web developers, that's what they do. Web client-side developers, that's what they focus on is the user experience. But still, given the tools and the platform, native wins. I'm seeing a trend. Features, right? I mean, this one's pretty easy. Accelerometer, photo uploads, the camera, push notifications, iCloud social integration. I mean, native has so many different APIs that they're accessible to them. And HTML5 is kind of lagging, right? It's behind. We're constantly trying to catch up. Monetization. With the App Store, with credit cards already put in there, with one-touch purchases, I mean, billions of dollars have already gone to developers to native apps. So, native wins. Look at that. This isn't looking good for us. So, luckily there's a third category here, which is a hybrid. It's a mix between sort of a wrapper for HTML5 apps. And although that doesn't really make up for most of these things, kind of gives us a little bit of leverage on these. At least features and monetization, we have 100%. I mean, we can access any features that we want as long as the native iOS gives us some sort of API to do that. But everyone's doing it, right? LinkedIn, Facebook. I mean, they're creating some pretty cool HTML5 apps, right? iPad, Facebook's got the mobile app. Oh, wait. Unless you've been living under a rock, you know that Mark Zuckerberg and... Oh, is that wrong? That's right, right? All right, that's our guy. So Mark Zuckerberg and LinkedIn both decided to revert from their HTML5 app to their native app. They both noted some similar things like tooling, memory management, scrolling performance, UI animations, and the GPU as reasons for the switch. A lot of developers are creating really cool things for native, given that it's just better inherently, and HTML5 is kind of lacking. So why HTML? Why would we create HTML5 mobile apps, native or on the web? I don't really know. Obviously, all you guys are saying, is he serious? No, not really. I mean, kind of. I don't really plan to get into this debate, the native versus HTML5 mobile. It's been talked about a lot of controversy. I don't really want to get into that. It's dirty. But there are reasons, of course. Like, obviously, the mobile web, you could supplement a native application. But at Belly, so Belly has three main devices or main mobile applications. We have the iPhone, the Android, and the iPad. So the iPhone and the Android are the users, like what the users would use to check in at our locations. The iPad is what they would check in to. So it's the merchant application that's facing you guys. So why would we choose to, what we ended up doing is we chose HTML5 mobile hybrid for that merchant app, and because it made a lot of sense for us. In fact, it not only made sense, but it transformed the way that we were able to innovate. And I'll tell you why. So if you're not familiar with Belly, we install iPad applications, much like this one, in merchants all around the country. We've got New York City, Chicago, DC, Boston, Austin, LA, San Francisco. We install in restaurants, in convenience stores, clothing stores, food trucks, marijuana dispensaries, nothing abnormal. And so users will come to these stores, they'll check in with their iPhone or their card, gain points using one account for all these different merchants. They'll earn rewards, free coffee, free brownies. Your own sandwich named after you, maybe that's one of the options. So we like to come up with some weird rewards. At one place we have, you can punch the owner in the gut. We like to keep it weird. So what was the problem, right? We had a native application, a native iPad application. And we decided that this wasn't going to work. Back when we had maybe under 1,000 locations in Chicago, and we had just opened up our newest market in Austin, we came to a realization. Native wasn't going to work for us. I mean, anytime we wanted to update the application, we'd either have to call that business and tell them to update it, hope that they'd update it on their own, or go into that business and update it ourselves. This was expensive and very, very time-consuming. I should probably put up the bullet points. Innovation slowed because of this. I mean, it wasn't even possible for the merchants to even update it themselves, I should note, because we locked it down. I mean, of course, we don't want them running anything other than our iPad application. So they couldn't do that. So it had to be us. Because of the time it took to update these applications and ensure that there was no bugs, because bugs could kill this app, we decided we needed another solution. Innovation was slow. We just couldn't come up with new features like we wanted to. So what was the solution? Well, what we ended up building was an HTML5 iPad app that felt native. I'll show you a demo in a second, but it was really important to us that we created something that was fast and quick, something that felt really responsive and it was enjoyable to use. But not only that, we could deploy the new version in minutes. So if we were iterating on a feature, if we created a new feature in the application, we could update it to all of our thousands of iPads. Currently, we have 6,000 iPads. We could do that in minutes. We could develop multiple versions. We could test it in different markets or different genres of merchants. We could put it in restaurants in Boston if we wanted to try a new look just for those. I don't know. Anything we could do, A/B test. And we were tracking all of these user events, so that gave us the analytics in order to confirm that those things were working. So one thing that I want to stress, I'll say this a couple of times, what we were able to do is develop this application within the desktop browser. And I know that sounds a little bit weird because it's not a desktop application, but it was an environment that was familiar to us, something that we understood, something that we knew how to look at the performance. So we ensured that our solution, even though it was a hybrid, so we had access to native APIs, which didn't work in the browser, we created a browser.js file. It was kind of like a polyfill. It was really, really helpful. So Mercante is what we call the JavaScript portion of the app. It's wrapped by a native portion, and I'll get to that in a second. But it was built on Backbone. At the time, Backbone was really the solid. Angular hadn't even really been released. Ember was out, but it wasn't really well used. There was so many more, but Backbone made sense, especially for a mobile application because it was small. But it was small, so there was very little organization to it. So what we did was we created Dogbone. This allowed us to keep a lot of our views and all of our models and everything very, very small and decoupled. This is really important because it allowed us to clean up things, manage memory for those particular views, remove event listeners, for example, when we're no longer using them. We could develop within a browser. Like I said, it's really important. And then when we were done, we could package and deploy to an S3 bucket, CDN, and that would be then available to the client to pull down. This is us working in a browser. I like a lot of tabs, so my browser is usually pretty slow. But as you can see, we've got we've got a bunch of information logging. We can profile, we can audit, we can see that we can manipulate the elements. It was incredibly useful for manipulating our application and seeing some of the general performance bugs. So Barco was the wrapper. And this isn't really HTML5, so I'll zip through it, but it allowed us to access some of the core native features using Cordova and also the Cordova framework for plugins. It made it incredibly easy to access pretty much anything we wanted. One example would be the QR scanner, so something that we couldn't do in HTML5, so we had Barco do it. The queue allowed us to run this application offline. So anytime we couldn't make a request, we'd throw it into Barco. Next time it was online, it would happen on another thread, so the app could run normally while in offline mode. And when it came back on, it would send it to our servers, tell us that somebody checked in so we don't lose anybody's check-ins. Oopsie, go back. I did not mean to do that. So the key value store, that was just an easy way of storing our models. Reliable way, heartbeats that would ping home every 10 minutes. Well, right now we have 10 minutes. We can do it anywhere between a minute and an hour. It'll tell our servers things like screen brightness and anything you think of, all the sort of health diagnostics of the iPad would come back in the heartbeat, so we knew exactly what was going on. The version switcher, though, was really important. What would happen is that when we were ready, we tell the client we wanted on this newest version, it would download all those files to the local file system, wait for the JavaScript to say it was ready when nobody was using the app, and then, much like this, it would come up, it would update the app, then it would go away. So the process this is really important because this is exactly why HTML5 was important for us. It was, I think, the only way at the time that we could do this. We could develop on our desktop, on an iPad, browser, simulator, whatever it was, package it up, run a rake task, it would package it, upload it to our CDN, and then we would tell the client, or a set of clients, or a single client, didn't matter, any of the clients that we wanted to download that application, and then once the JavaScript was ready, the user wasn't using it, it would refresh. So looking back at this screen again, I want to note that everything on the screen is HTML5, or it's JavaScript, CSS, HTML. Nothing is native, except for this one screen where the scanner, of course, you're scanning your QR code, which is something, unfortunately, we can't do in HTML5. But the important thing is to note that the UI in itself, other than this one screen, is entirely HTML. In this example, you'll see, I'm going to show you this video of the iPad running, just to give you kind of an idea of how quick and smooth it is. This is sort of just an animation on the home screen. I'm sorry, this scroll is forever. But anyway, it's just a way of showing that businesses rewards and drawing the attention of the member that might be walking by, or the customer that might be walking by. So anyway, normally you'd go in, scan a QR code on the scanner, you'd have your rewards, these are your points. You could also go in, if you have enough points, redeem a reward, like this. The contrast is pretty bad, so it's hard to see, but boom, so reward. See, everything, we want to make sure that everything was quick and responsive. You click, it switched, animations were smooth, nothing was super choppy. In this screen, this is sort of the back-end system, something that would give access to DMs, to decision makers and partners at that business, or admins at Belly. So that's it, but that's our application. That's all HTML5, JavaScript. So what were the nightmares? Other than that mask, there were some difficulties in creating this iPad application. It wasn't easy. It's still not easy, but hopefully I can share with you guys some tips on how we made it a little bit easier. So what were the problems? There was tooling. You can't really get access to things. It's a lot harder to see the memory usage of the JavaScript application. Rendering. So by default, most of the tasks are handled by the CPU. Rendering has to, especially on mobile applications, you have to upload that onto the GPU. You're not going to get a good experience if it's on the CPU. The graphics processor unit is really good at rendering graphics and complex graphics. So upload it to the GPU, I'll tell you in a bit. But DOM. So the DOM obviously has always been a problem. That's not new. But in mobile, it's even more crucial, particularly repaints and reflows, which I'll get into in a minute. But memory management, pain in the ass. So first thing we had to do is forget everything we knew. We had to relearn. Relearn everything we knew about web development, about JavaScript libraries, about the DOM, about memory management. We had to really ensure that we knew what we were getting ourselves into, because we were no longer dealing with desktop applications. So we had to evaluate our advantages. I'll be honest, we had some pretty good advantages. I mean, we could guarantee that we were on an iPad, although we did build it and try it on Nexus 7, which went really well. It's just we still prefer the iPad. We could guarantee that it was on 5.1 or above. We could optimize for continuous runtime, so that means we could offload a lot of the heavy lifting when it first boots up, because normally a user isn't there using it at that point. And I think that's about it. Also, it was the only app running, so we had a little bit more memory. Tooling, right? I wish I had more for you guys in tooling. It's really came back to our normal environment. Instead of trying to haggle with testing on the device itself, or using any sort of the we could use some of the Xcode tools. We could work inside of Xcode, but most of the time we were working as if we were building a normal web app. I used Sublime and Chrome. I know it's kind of weird, Chrome, not Safari, when we're building an iPad application, but I like Chrome. It's much better, and the dev tools allowed me to get a better look at it. But when I needed it, I could use the remote web inspector in Safari. I don't know if you're familiar with this, but it was introduced in iOS 6. This is incredibly useful when you really want to get into what's happening on the device itself. Essentially, what it allows you to do is use the web inspector to inspect. It could be a simulator or an actual mobile device, or iPad or iPhone. I don't like it as much as the Chrome toolbar, so I did a lot of my development within Chrome. When I needed to, though, this was handy. It's really easy to enable. All you have to do is go to Settings, Safari, and Advanced on the iPad and turn the web inspector on. After that, you go into Safari, develop iPad simulator, pick the simulator. At this point, it was the index.html of the merchant app. So memory. Memory to JavaScript developers and to the browser, really, it's kind of a black box. And JavaScript developers tend to say, meh, the browser will handle it, right? Garbage collection, it's there. And generally, websites and even some web apps don't really have to think too much about memory because you're constantly refreshing that view. But memory leaks can become a huge problem when you have an application that can run for hours on end. Belly's iPad app, sometimes it's running for often hours or days, but even sometimes weeks. So without closing. So we had to make sure that memory was, there was no memory leaks. I'll be honest though, memory it's pretty tough in mobile web, mostly because it's difficult to get a really good look into the device itself. But if you understand memory and if you understand how to sort of find some of the bad patterns, it becomes easier. So I used the Chrome to track down some of the major issues that we had. Karan Prasad, Senior Director of Mobile Engineering at LinkedIn, said the primary reason for their switching from HTML5 mobile to native was that that they were seeing more and more people were spending more time in the app, and the app was running out of memory. I've never seen LinkedIn's code. I don't know what it looks like. I'm sure it's pretty good. And somebody like LinkedIn, I don't think HTML5 makes sense for, so I'm not going to argue this. But if somebody's spending more and more time in your application and your memory is adding more and more, you're adding more and more in memory without deallocating it, then yeah, you're going to run out of memory. So it's really important that you understand garbage collection and how sometimes it doesn't work the way you'd think, and ensuring and always thinking about deallocating the memory that's no longer being used. So garbage collection, what is it? Well, garbage collectors attempt to find objects that are no longer being used and frees up memory. It's how browsers reclaim memory in JavaScript. It's a process that happens behind the scenes. But this convenience comes at a price. So this is the extreme, but at its extreme, garbage collection can take up to 6 times the necessary memory. On a mobile device, that's huge. But garbage collection also doesn't eliminate all memory leaks. It's still possible. What are memory leaks? Simple. It's the failure to release discarded memory, or to release memory that should be discarded, or otherwise discarded by your app. You're no longer using it, but the browser still is storing it. JavaScript events were a common problem. We eventually realized that we needed to be very, very careful about adding events and detaching those events when we were no longer using them, or ensuring that we weren't accidentally adding over and over again. So let's take a little 101 into garbage collection. If you don't know how garbage collection works, hopefully you'll get a better understanding. If you already do know, I'm sorry, this is pretty rudimentary. So we have a test function, right? In this test function, we'd probably be running some complex logic. But for the sake of this example, we're just going to focus on a variable. This variable is going to allocate, the memory is going to be allocated for this string when my variable gets instantiated, and then at the end is no longer being used. So it is available for garbage collection. If we have, in this example, we have another variable outside of that test function, right? So when we run that test function, we're referencing that same my variable with something that's outside of that scope. It's pretty simple, but obviously that another function now referencing that string is no longer, my variable is no longer going to be up for garbage collection. So in this example, obviously it's really simple, and a string isn't going to crash your app. But eventually you can see if you have a very complex application, something like the Belly app, where you're constantly working with data, creating new objects and new users, for example, you've got to be careful when referencing your anything. I mean, anything that's been allocated from memory, it needs to be discarded if you're no longer using it. One thing that's worth noting is window.performance.memory. Unfortunately, this isn't available in Safari yet, at least, but it is available in Chrome. So if you're using Chrome to debug your app, this is available to you. In fact, Gmail uses it solely to monitor their performance in Gmail through all their users. So this would be really cool once we are able to put it on mobile devices, because then we could actually, send alerts and such if we've got too much memory. So Chrome or any web inspector is huge for developing on mobile. Oftentimes when we're developing for the web, we use the Elements tab and the Console tab. You really need to get used to all these other middle ones: resource, network, sources, timeline, profiles, audits. The timeline in particular, though, will give you a good look at your memory. A memory leak looks something like this, where it keeps going up, and never goes back down. Garbage collector should come around, and it should be like this. If it's ever going up and up and up, the more the app is running, the more likely eventually it's going to crash. So rendering. Rendering was probably one of the most important things in this app. We want it to be very fast. We want it to be responsive. And we wanted it to be enjoyable to use. And I don't know if you've ever created a mobile application, you know that mobile devices suck at rendering within the browser. There's a couple reasons. But some of the things that we did to help this was our app is a single page. It never refreshes. Unless we're loading a new application or we're deliberately refreshing it. Every single page, every single element lives within this one HTML file. We load a lot of our main views, so anything that's used on a normal basis, most of those views that you saw, in particular the main screen, the check-in screen, and then where you would redeem your rewards, and all of the other elements that come along with that. Sometimes we have like a little Facebook banner, sometimes we have different messages for if you're offline, or all those elements that are common, we always have it on the page. In this image, you can see there's a bunch of like assets sort of off the screen. This would be the iPad, and all those other elements are translated using Translate 3D off the screen. That gives us hardware acceleration to translate it off. And it essentially caches that for us. Bringing it back on is incredibly fast and is not at all like re-rendering it. The DOM is a mess, right? We all know that. But I want to focus on repaints and reflows. So if you're not familiar with repaints and reflows, it's essentially the web browser's process for recalculating the positions and geometries of the elements in the DOM. But repaints and reflows are really expensive. And the reason for that is when it's happening, when it's repainting or when it's reflowing, it stops all other processes. So if you're continually adding and removing things from the DOM constantly, you're going to have a lot of this process, and it's going to slow down your app. One of the ways that we were able to get around that, or help that at least, is document fragments. If you're not familiar with document fragments, it's pretty easy. All you do is document.create document fragment. That gives you an object that essentially represents a DOM node or a set of DOM nodes, but it's all in memory. So you can still manipulate that. You can still add elements like this. You can append child. You can manipulate that almost in any way that you would in the DOM, but it's much, much faster because it's in memory and not in the DOM. So this allows you to, I'll show you this real quick. This is jQuery's, jQuery makes this incredibly simple, or Zepto. If you add a bunch of HTML within a tag, I mean, you've all probably done this, what it does is creates a document fragment. And that allows you to manipulate that in any way you could with a normal jQuery object. You could add a class, you could add some text, you could add some more elements, you can reference, store a reference to one of those elements, you can add some events which won't occur until you actually put it in the DOM, but you can at least attach them before they're actually in the DOM. This allows you to do all these stuff without having to query the DOM or deal with it in any way. It's really great, right? So when we were creating our application, we would make sure that anything that we did, in fact, I think I talked about Dogbone earlier, and Dogbone behind the scenes sort of makes this really easy. So anytime I was rendering something, it would go through all of its children, and anything that has to show up on that page, it would all get dumped into a document fragment. And so it would build it, I would store references, I would attach events, all before it actually went into DOM, and then I'd dump it all at once. Make use of the GPU, right? The GPU, it's the graphics processing unit. Like I said before, it's kind of a black box. But it's critical in mobile environments. And it's great for complicated layout compositions like CSS3 gradients, text shadows, images, etc. By selectively adding hardware acceleration to elements that trend slower, we were able to offload some of those, that rendering to the GPU, which is incredibly fast. One thing to note about hardware acceleration, I know you've seen blogs, right? There's tons of blogs about hardware acceleration, but they all tend to be around transitions, making smoother animations and such. One thing that we used hardware acceleration for mostly was just simple rendering. I mean, if you have an element with CSS properties, for example, GPU would speed that up incredibly, even if there was no transition. So one screen that I didn't show you earlier was the iPad. Sorry, the iPad, the keyboard screen, which is either for registering or checking in with your email. If you note, so everything on the screen is CSS3. There's no images, and the keyboard in particular. We couldn't use the custom keyboard that came in the browser because we just didn't have enough control over it. Not only could we not theme it or add buttons, it was also troublesome to get to pop up. I think in iOS 6 it's a little bit better, but we couldn't force focus on an input unless there was a direct event from the user. So checking in or trying to register a new card didn't involve an actual DOM user event. So we couldn't pop it up. So we had to rely on the user to click the window, which just didn't make any sense. So what we did was we created our own. Everything is HTML, CSS. That's not even a, well, I mean, not that it wouldn't be HTML, but that input is completely custom. There's a blinking, whatever you call those things. That's a div. And the rest of it's just text in a div. It works like it. I have a video I'll show you, but it works just like a regular keyboard. You couldn't even tell. I'll show it to you. So this is slowed down, but in the first screen, this is without hardware acceleration. So this is gonna, you'll see, block in. It's slowed down, but in real life, it's still quite slow. You'll see. I'll show you the fast version. You'll see the difference, but or the hardware acceleration version. I mean. So you can see like it comes down. I mean, it's blocky. Nobody wants that. But most importantly, when the user went to click on each of the buttons, there would be a slow response time. They'd click, and it would take about maybe, I don't know, half a second, maybe a little less, but whatever it was, to show up there and here. So when you normally type on a keyboard, you're probably typing as fast as this. You probably get done your email before we get halfway through the email on the screen. So it wasn't ideal. So how did we fix this? I mean, it's pretty simple. You've all seen Translate 3D. But all it took was you put Translate 3D on the keys and on the overall keyboard. The two things mainly that have the CSS gradients, and the key itself was obviously had a click state. So putting that one, ignore these for a second, that one Translate 3D on both of those elements made it incredibly fast. I'll show you. But I wanted to note these other ones, the Transform Translate Z, Perspective 1000, Backface Visibility. In iOS 6, they got rid of, or Translate 3 doesn't always enable hardware acceleration. So at times where I noticed it wasn't, I could just throw on these, and generally it would. So this is a slowed down version of us adding the hardware acceleration. As you can see, it's instant. Real quick, we'll do it one more time. It's really slow. All right, so you can see it's almost instant. You can't even tell. The response from a click is also incredibly fast. You can't even tell. I'll show you in the next video. It's actually sped up to real time, so you can see. But easy, right? Quick. Feels like a native keyboard, as you can see up there. Response right away. Inifu, I don't know what that is, but there we go. So in closing, one of the largest problems we found with creating an HTML5 mobile app wasn't just the platform. It was the techniques, the habits, the tools, the libraries that we used in traditional web yesterday. By adapting to the latest standards, techniques, and truly understanding the DOM and the browser, the platform became less of a problem. So again, my name is Dave Arel. You can follow me at Dave Arel. Actually, if you've ever created a mobile app, I'd love HTML5 mobile app. I'd love to talk to you. You can either come talk to me afterwards or tweet me, email me. I'll give you my card. And then also go view tech.bellycard.com. We're blogging about cool things all the time. I say all the time, but it's only been out for a couple weeks. So, all right. Thank you. Oh, yeah. Anybody have questions?
That was a great talk. It sounds like
Thank
you guys
you.
have some really interesting performance considerations. You'd mentioned a bit about the JavaScript memory management.
Yeah.
I've actually got a few questions I can tell you later.
Yeah, sure.
But as far as the JavaScript is concerned, you put that link by LinkedIn where you said that their app kept running out of memory.
Yeah.
But that seems kind of, to me, I mean, just going off that quote alone, it sounds like they had bugs because
Right.
that would imply that they're not releasing the memory.
Right.
Exactly. You can mark things as
Yep.
eligible for garbage collection, therefore the garbage collection
Yep.
takes care of it. However, there can be pauses. And I'm wondering, in your experience at Belly, if you guys had to deal with a lot of memory issues, either, I mean, not counting bugs that you guys introduced, but like just browser limitations where the garbage collector takes too slow, or there is some sort of weird thing where memory does get trapped and you can't do anything to free it. Do you have any kind of experience like that?
I don't think we've had any memory that's been trapped that we couldn't free as of yet. I'm sure there's some browser bugs that would allow that, but what was the other part of the question? So,
if you had any issues with garbage collector pauses
right.
during the user experience.
Well, the thing about the garbage collector pauses is they stop all process. So if we were doing something very heavy at that time, it would slow it down. So I don't know if we've seen any that have particularly been a problem. But yeah, I mean, like I said, garbage collection is really inefficient, and it does, pause the application and all that's running. But usually it's pretty quick if you're constantly, keep taking care of your memory. We don't have anything. I mean, LinkedIn has a bigger issue, right? Because they're dealing with a ton more images, ton more content, people scrolling through and constantly loading new data. So I do think that that's a very, very tough situation. But you're right. I think it does indicate that it was buggy because they should have been releasing that memory in some way. And they have blogs that talk about how they dealt with scrolling performance and such. So I think they were thinking of that stuff. I don't know. I'm not sure, but it does indicate that there were bugs.
I guess only they would know, but it sounds like just by that quote alone.
Yeah, exactly. I think the thing that's important to note is that web developers come from a web environment where they're not really thinking about these things, where they're not used to them, and they're not they rely on the garbage collector too much. So when you're coming from web to mobile, and I don't know what kind of team they had, but who knows? Maybe they've just got a lot of web developers who just aren't thinking like mobile developers. I don't know. Any other questions?
Can you tell me about a barcode? I'm not familiar with that piece of it.
Barco?
Yeah, please.
Yeah. So can I tell you about it?
Yeah, please.
It's essentially an extension of Phonegap. We don't use much of Phonegap, but it was a good base. So it's Phonegap, but highly customized. We've built a whole bootloading system so that it would download the assets and store it locally. Phonegap just gives you the ability to throw some files into the file system and and load them from there. So we created an application that would dynamically download applications and change the web view based on those new files. Does that make sense?
Yeah, so you added the extensions to it, it's basically what you do. And
Yeah.
that's your proprietary.
Yeah, it's highly customized. We've talked about making it open source though.
That would be nice.
Yeah. We work a lot with eSpark, which is in the city. It's like a education thing, and they do pretty similar things. And they're like, please open source it. So I don't know. Maybe we'll work with them to open source it, and then maybe you can criticize our code. Any other questions?
So I said a thing translate 3D, and I can understand that loading the keyboard faster, but I'm not quite sure how it made it more responsive. Or was that the
So it was slow. The responsiveness was really slow before we added hardware acceleration because that click event would re-render that it had another gradient on there, so the browser would then have to go through the process of generating that new image. So adding hardware acceleration made that incredibly faster. I use incredibly a lot. I'm like Steve Jobs, but did I just compare myself to Steve Jobs? So yeah, that process that happens there slows everything. It stops while it's re-rendering that. So the time that when it wasn't showing up in the input field or something like that, and it wasn't click state was a bit afterwards. I should have showed you a faster version of it so you could see real time. It just feels really laggy, but it was because of that one render.
You're just tricking the browser into using the GPU.
Yeah, exactly. It's a hack, and hopefully they won't take that hack away from us. What's up? How are you doing?
Hi. So one of the things we found when we looked at HTML5 is it appears that HTML5 at the moment isn't very good at handling this.
Yes.
And it isn't very good at
Gesture actions. What did you say?
recognition.
Gesture.
The way it
Gesture.
handles,
Right.
it handles events
Correct.
in a way that even
Right.
induces.
It's not as responsive. Yeah.
Gesture recognition. How do you get some movement?
Fortunately and unfortunately, we haven't really had to deal with too many gestures yet. I do think that would be a problem. I mean, you'd have to be incredibly, probably creative in order to. You might not be able to get the same experience, but the lists, yeah, the lists are. We have dealt with those, and they are incredibly difficult. It's mostly because of memory. You can continually scroll. You're loading in more and more and more memory. And then you can't just get rid of those elements because then it'll jump, you know, in the scroll. So, and then if the user decides they want to scroll all the way back, you have to quickly load that back in. So yeah, it's a pain in the ass. I think if your application is probably, if your application has a lot of scrolling like that, or, you know, Facebook and LinkedIn are probably bad applications to start trying to use at HTML5, which is one of the things I want to, you know, drive home, is that if your application is not quite like theirs, maybe you can have a really, really fast HTML app. But yeah, lists suck. So don't have lists and your app won't suck.
I done a few stuff. I've tried to open the update, you know, this updated JavaScript,
I have not, but I sure hope so. I'd love to, if you could find it, I'd love you to send it to me.
Does your app have an authentication piece?
Does what?
Does your app have an authentication?
Oh, yes, it does. With all the users, and I mean, every time when you do a check-in, we authenticate you. It's all handled at the API. We have a very RESTful API that we work with.
You said that JavaScript events were a problem with memory. How did you take care of that?
So with Dogbone, I want a better way of doing this. I want like to basically blacklist it from certain areas. But we just made sure that if we were using it, so we had a method called activate and deactivate. So when those views, and those views are very small, when those views are about to be used, if they're you know, kind of called to action, they can then add events or anything that is necessary to sort of invoke it. And then once it's done with, there's a deactivate method, so then you could remove those events. But sometimes we would just attach the event on a method that only got ran once in the beginning, run once in the beginning. And because we were using document fragments, we could do that before it was even in the DOM. So that, I don't know, it just gave us the ability to sort of attach the event once and never have to worry about it. We knew that method wasn't going to run again. Anybody else?
Push about your animations. They look really good. They're
Thanks.
like 60 frames per second, but I noticed that using easings that have like a bounce, and that's not built into CSS3.
Well, you can use but I don't know how to say it.
Bezier curve?
Yeah, something like
Oh,
that.
so you're just using like cubic Bezier.
Yep.
Okay, so it wasn't. Like,
Well, it depends on the animation. I think some of those bounces might have just been. We built this. Well, we use a couple animation libraries. There's a animate.css. Have you seen that? Which some of those bounces come from. It's a good library. It's very slim. That I think was from that, and I think it's just translating it. So it's translating it a certain amount of pixels up and then down and then up and down.
Right.
So yeah, it's just sort of I don't know. It's just a.
I guess my real question was, it looked like using CSS rather than JavaScript.
It is CSS, yeah. It is CSS. The JavaScript adds a class to it, and we run a bunch of timers. So for when those classes get added and removed, and the CSS handles the actual animation. That is pretty much the only way. If you use JavaScript, it would just be incredibly slow and not smooth.
What's the library again?
Animate.css, I believe it's called. Anybody else? I saw a couple of yes.
It should be known that Translate 3D is not a. You should use it very sparingly. You have to focus it to what you need to do. If you put it on the body, you're going to have these problems where the app will crash. Yeah. And you won't know why.
You'll overload the GPU. And also there's some weird CSS issues that happen, like with positioning. You can't position things. Things will end up in obscure places. What I do is I originally build the application the way I'd want it in the browser, and then I put it on an iPad. I play it. If there's buggy portions of it, I narrow down what the biggest issues are, and add CSS translate 3D to that element.
The other thing with document fragments is that I've done a lot of some of the stuff that you've done for performance.
Cool.
Document fragments by themselves are fantastic. The way that you've shown it with jQuery because jQuery natively wraps a lot of its stuff in its own methods, the jQuery version is about 6 times slower than traditional document fragments.
Yep.
But because it's slower, you gain the advantage that it's simple to use, as opposed to if you were to do a document
Yep.
fragment that had built what he did, you end up expanding the code base to get very simple stuff. So again, when you're developing your apps, you have to kind of make the determination as to whether or not using jQuery
Yep.
is simpler versus the speed of just kind of native fragments.
We're because we have the advantage of iPads. We were able. I use Zepto. It's a little bit faster in some things, but that was because at the time they had jQuery just supported still IE6. I will probably switch over. I'll try it. I'll see if the performance is any better. But jQuery 2, I think, right, has much better browser support.
I think
Better, I mean less.
jQuery up there is known as the slowest way to do it. You can do it with jQuery and still have it just as fast as JavaScript. Still do it that way with a string that has bars.
Well, you're saying that you can use document fragments with jQuery without.
You can say like where you had a string that has two bars, you can say document.create elements and there, make your tag, goes straight to jQuery, just passes it straight.
Probably, you might end up writing just as much code. Well, because if you're manipulating it with jQuery later, it's probably still just as slow. I don't know. It definitely, like, if we were using mobile apps, we'd probably get rid of jQuery. And if we were just mobile apps, we'd probably just write straight JavaScript. It would be more efficient. It's just more pain in the ass. That's all.
We'll do the same API for the document fragment, it's called, but you just pass it a string of HTML, right? No, I'm saying
jQuery.
There's lots of different ways to instantiate jQuery with some memory-based DOM.
Right.
And the way he did it, just for example purposes, because I know that you know that's the slow way to do it.
Yep.
As a string is just the slowest way to do it of all the ways. That's all. Okay.
Anybody else?
Do you also have a desktop app, like where people can go in and check their balance and stuff like that?
We do, yeah.
And does it come off the same code base or?
No, I mean, it's all using the same API, but it's different code base.
Can you talk a bit more about the self-updating piece? Are you just updating certain modules, or if you're updating a whole bunch of JavaScript, aren't you going to then refresh the page at that point, or are you just kind of loading JavaScript onto JavaScript?
So the way it works is that we'll have multiple folders of different versions within that device itself. So when that app is told it needs to be on a newer version, it'll download everything on a separate thread. While the app is running, it'll download all of those to a separate files, a separate folder in the file system. And then once JavaScript says it's ready, the native app will come up with that screen, come down, and it'll refresh that web view. Does that answer your question?
It refreshes just that whole.
It'll refresh the entire app. Because at that point it's on the home screen, it's just refreshing back to the home screen. The user can barely even tell, even if they're there. I mean, it just comes up, comes down. It's a whole new application. Right now we download everything for a new application, so it's compiled into something we call package, which is just a representation of all the files in a JSON file. So, yeah, I mean, does that answer your question?
Yeah, I wasn't sure if you were refreshing the page or not, if you were actually still keeping on that single page app, but just updating certain modules.
I mean, at some point we could probably like just update a portion of it at a time, I guess. But right now it just made more sense to just keep it simple, update the entire app, refresh the web view.
If you release 10 versions, do you have 10 folders of a version each?
We only keep the previous version, just so that if we have to revert.
You have a self cleanup thing on the actual app that release that?
Yep.
One more? Dogbone, is that another proprietary thing, or is that?
It's ours, yeah, we wrote it. It's just an extension to Backbone. We originally called it Belly Bone. Yeah, exactly. So we renamed it. But yeah, we created it. We'll probably open source it at some point.
So you're mentioning the JavaScript performance. Is this just strictly because of on the iPad itself, or were you finding that as you were working this on your desktop, that the JavaScript also still there, or is it really just the nature of JavaScript on that?
I mean, anything you do is slower on the iPad. The browser generally handles that stuff pretty well. You're talking about the document fragment stuff?
I think just in general, I mean, because I've found, in my own experience, I found JavaScript quite forward. Work well, and so I didn't know if it's a thing, but I haven't done a lot of iPad.
Yeah, generally I'll develop in the browser, and it'll be smooth, fast, efficient, and then I'll port it over to the iPad, and it'll be choppy and everything until I start optimizing it. Particularly with the CSS hardware acceleration. So.
Right on. I have one question. How many people biked here tonight? Not a lot of helmets coming. Good job. Thanks, David.
Yeah, thank you. Thanks, guys.
I have stickers too.
Oh, yeah.